Start the recording. Brad. Okay, you guys want to kick it off?
Sure. So just going to introduce Pavani. She's my outreachy intern working on the Ceph shell. Idea of the Ceph shell is to have an easier utility to access the Ceph file system other than mounting it through Fuse or mounting it with the kernel client to allow you to do some simple things in scripts without having to go through all the trouble of mounting. So with that, I'll let Pavani introduce herself, say anything else she wants to say, and then I can also play the demo that she's prepared.
Cool, sounds great.
Hi everyone, I'm Pavni. I'm one of the outreach interns 2018. That's it. Today I'm going to give a short demo about my shell I'm working on.
Okay, I'll share my screen. All right, can you all see?
Mm-hmm.
Okay. Sorry, I have to play Sorry, that didn't work very well. I just realized I don't know how to play the audio through my computer. So
You want to pipe the audio from the video back through? Yeah, I don't know how to do that.
I could do it with Pulse Audio, but not on the fly.
Yeah.
So I just
talk
Will I demonstrate now? Is it fine?
Pavani, why don't you go ahead and talk through it, if you can, or are you able to play the video yourself?
Live. Oh, should I play or should I show you now itself? I'll demonstrate it now.
If you can play the video, then you can do that.
Yeah, I'll try.
I'll stop sharing.
Can you hear? Can you hear it?
We can't actually hear the video. We can hear you talking. I think I'll have to narrate. Play the video and then narrate.
Yeah, I think just go ahead and try to repeat what you're doing in the video, Pavani.
Yeah.
I guess you could post the link in the chat. We could all go and watch it, make sure the link's available with this recording, and then resume after everyone's watched it.
I think probably the easiest thing is if you just narrate over the video as it plays.
Sorry. Should I play the video?
Yeah, I suggest just playing the video and then talk us through it, since the audio that's already recorded won't be picked up by Blue Jeans.
So Pavani, just go ahead and talk about what's going on in the video. Don't worry about the audio in the video.
Yeah, okay, fine. Okay, till now, I have almost reached the half of the internship period, and I've worked on various commands like mkdir, du, df, get, put, and so on. So now I've written the complete shell and CMD2 module, and you can see here the demo. First, I'm listing listing all the files in the directory. And now you can know what the command does by using a question mark before the command or using a -h. The question mark is a shortcut for it. And okay, I've implemented many options for each command. Now I'll try to copy a directory tree from the local file system to the Ceph file system. To make it more interactive, I've also implemented the feature of autocomplete. And you can see the desktop folder from the local file system is copied here. You can also run the system local shell commands in this shell by using a exclamatory mark before the command. You can see all the these are the files in the Ceph file system, and these are the local one.
When you do a put, is it trying to preserve the owner and mode?
Sorry.
I'll ask at the end. Go ahead.
Yeah. Okay. Now I'm trying to change the permission of a file here. You can see the initial permission of that file is this one, and the changed one is this one. I've also been working on providing an API to change the UMask as well. So you can see the default UMask is, and you can also change it from the shell. I've also implemented globbing file names as well. So you can do something like this, giving a pattern instead of a file name. Showing that because it's not an empty directory. Now we can see there will be no folder in the desktop directory which starts with a A. The shell is knowing the previous history of the commands and also aliasing a existing command. So for example, here the regular ls is just listing out the directories in the directory. Instead, I'm aliasing it as a ls hyphen l. So now whenever I type a ls, it will be ls hyphen l. So now the du command, the du by disk usage of the current directory, and du hyphen r gives the recursive subdirectory disk usage. These are the commands I've been working on till now, and I'll be working on implementing more commands and options for each command. If you please let me know if you want me to work on any particular command or any specific to the shell. That's it. Thank you.
All right, that looks super cool. I'm very impressed with all the stuff that's in there. I think my first question is it possible to call the shell command and execute a command from the command line? Because I can imagine one of the uses of this is if you're just writing a script and you need to just call to like put a file or set an attribute or something like that. You don't actually want to run it interactively, but you just want to script it. So I can imagine cases where there's just like one command that you want to execute, or even a case where you want to just like pipe to standard input like 3 or 4 commands or whatever it is.
Yeah, I think that's one of the use cases we want to support is being able to specify a command on via the arguments and then also potentially execute a batch file.
Batch file.
But it doesn't do that yet.
Yeah. Okay. What was my other question?
The UIDs and GIDs input.
Oh yeah, I was wondering if put tries to preserve like file mode and user and all that stuff.
I don't believe it does that yet. That's
Yeah.
something we need to fix.
Yeah. Okay.
So the other thing that was in the video, but Lonnie understandably forgot to mention was the next thing she's going to be working on is doing the testing for the shell and tautology, and also getting the code ready to be merged into Ceph, and then just do incremental improvements on it afterwards.
Awesome. Okay.
Yep.
Yeah, I think from my perspective, the things I would look forward to the batch thing, or even just the ability to do a one-off command from the command line. And then the one other bit of feedback would be that when you're creating a command that echoes something that you have in the shell, you should try to match up the arguments, order, and behavior. So like I noticed chmod, you flip the order of the mode and the file around. Might as well make it match the one that people are used to. Or du, by default is recursive, and so probably make your DU the same way and do the -s to be non-recursive, or whatever it is. Although I guess DU is probably just showing the stats, right? It's not actually walking the directory tree.
So I actually suggested for the DU command we do it in reverse. I think the normal behavior, the vanilla behavior of DU is that it walks the entire tree because it needs to do that anyway.
Yeah.
But for Cephfs we don't. So I thought it'd be,
Yeah.
you know, in the interest of having it be fast, we would just make the default behavior look at the top level directory. And if you want to look at all the underlying directories, you have to pass an option to do that, which is the opposite of the Unix behavior, but I think it makes sense for Cephfs.
Yeah. Yep, I think that makes sense. Okay. I guess one other thought is one of the things that always confuses me or annoys me about like the Rados put command line is there's positional arguments for like the object name and the file that you want to use as input. I think the put here works the same way, where one of them is a local file name and one of them is the remote path where you're going to copy it to. I wonder if there's a way we can make it mirror like a CP command where it's source destination, and then make it so that instead of having it be sort of implicit which one is the local file and which one's the remote file, instead make it have a magic character like tilde that means local file system, and then the absence of that means remote file system. I don't know if tilde is the right choice because you would expect that to be your home directory, but then you could use CP to copy things within the file system or to or from with the same command. That'd be too weird.
I mean, it's not a bad idea. Yeah, and we could use like URLs or something, but that's a little long to type.
Yeah. Yeah, I'm just thinking something like tilde, but I don't know what the character would be. Anyway, just a thought. Cool. Okay.
All right. Any other questions for Avani? All right. I guess we're done.
Oh.
Thanks.
All right. And I think the only other thing on the agenda is Josh put up backfill optimization brainstorming. He has an Etherpad with that.
Yeah, the Etherpad's empty right now because I thought we could fill it up with some ideas.
All right. I gotta go for like 1 minute. I'll be right back. Okay. Go ahead and start without me.
Sure. So I guess the background here is that with the way backfill works today, one of the reasons that it's slower than regular recovery is that we have to scan the entire disk to see which objects we need to recover among different replicas, because we don't have a way to tell which objects have changed since we were last up to date. And with normal recovery, if we have the PG log to tell us exactly which objects have changed in that time period. So it's simple. And one of the reasons that we wanted to look at backfill in particular is that with faster devices, it makes a bit less sense to rely purely on the PG log, because when you have, say, a device that's doing 50,000 or 100,000 IOPS, we're not going to be storing that many log entries. So it doesn't really give you very much of a time window to be able to tell what has changed when you have a super fast device with regular recovery. So that's kind of why we want to look at maybe optimizing backfill more for faster devices. And one of the idea that we kind of talked about at a high level before was trying to use a Bloom filter of some sort. But when I was trying to discuss this with Greg before, I realized I didn't really have a good concrete idea of what this would actually mean. So I'm not sure if Sage, if you had a good idea there, or.
I have a rough idea that I'm sure we can flesh out a bit. So the idea would be that once we, I guess we wouldn't know whether we're going to fall out of log recovery or not, so we would just maintain a bloom filter in general for all ops.
Right.
So we would probably have to do for like segmented time intervals, so like maybe a bloom filter every 10 minutes or 20 minutes, and then depending on how much of a window you want, you keep n of them. But the basic idea would be that you would just insert, similar to the hit sets, you would just insert any hash ID or object ID or whatever it is that you touch, whether you're doing an update or a delete. And so then when you're doing backfill and you're doing the backfill scan, you would just prune everything by the filter or set of bloom filters that matter. So if there were, if you only had one backfill target and say there were two bloom filters that cover the time interval over which you have to do your backfill, then when you do your scan, you would still have to enumerate all the objects, but you would just literally skip anything that isn't in the bloom filter. And then if it is in the bloom filter, it would go into the backfill map or whatever it's called. And then backfill would work normally. And you would, on the other end also, when you're applying it, you would have the same bloom filter, and so you would just ignore any entry locally as well. And you'd have to tweak the reconciliation code for deleting or modifying objects or whatever so that it just, and so basically, you wouldn't have as much metadata flying back and forth between the peers. You would still have to enumerate the objects, but in Bluestar at least, that's pretty fast.
But if you're gonna do a full scan of the objects on both sides anyway, it seems like you could do something much more efficient with like building up Merkle trees rather than having to maintain bloom filters live. That's it. Like if it's not skipping doing I/O, then I don't know what the point of online.
Well, it's
skipping metadata is.
It's reducing the amount of metadata that has to get processed and packed into a map and sent over the wire and packed on the other side. The I/O is actually pretty cheap. In the case of Bluestar, you actually have the O node already when you get the key name. And so you're not necessarily saving I/O, but you're saving all the CPU involved with unpacking it and decoding the O node and figuring out what the size and M time and what the version attribute is. Actually, that's what you're pulling at. So it would save CPU time. It wouldn't really save, and it would save network I/O, but it wouldn't.
I'm not sure that it does actually save CPU time though, because bloom filters aren't cheap. Like I don't know how expensive they are, but there's a lot of computation going into building up those hashes and maintaining them.
So the way that we implemented the hit sets, the way that we did the hit sets, we reused the hash that's already on the object, but we didn't actually calculate the hash. We just had to take that 32-bit and insert it in the bloom filter. And if I recall correctly, the way it did it was it actually used the same hash function with a different seed. And so it was a relatively non-complicated hash. We can check it again. My recollection was that it was pretty cheap. I think it's definitely cheaper than decoding the O node and pulling out the attribute. That involves lots of conditional branches. It involves memory allocations to pull out the xadders, maps, and all that stuff. But setting that aside, how would we do it with Merkle trees? I guess how would that work? Never actually.
I mean, a Merkle tree is just a tree of hashes. So what you're actually trying to do is like not send all the data. If you're just trying to send not all the data, metadata required, like say here's sort of a like hash the O node or whatever, and you build up, and then you do a binary tree, and so you only look at the ones where the hashes don't match, because you can just descend down the root to both sides. Or it doesn't have a binary tree. You can construct it in a variety of ways, but basically you're just trying to like skip over the ones that aren't different.
So in that case, would you still on both sides scan the object space and build a Merkle tree of what you
Yeah,
find, and then compare the two
yeah.
trees?
Or actually, you can even just like, if you know, I guess if you're scanning anyway, then the target could actually just be like, oh no. But you might actually, you might be able to do something where it's just with the versions actually. You're scanning the whole thing anyway. This assumes, of course, you actually have the ONO, but
Yeah, but then you have to decode the unknown and do the same. Yeah.
no, I was not thinking of trying to avoid decoding the ONO to take this target.
Yeah. I mean, we could probably construct the O-nodes such that we know there's going to be a version attribute on the object, and like we put it at the very beginning or something, so that we can find it cheaply. And we sort of have this like special optimization for getting that one function. Another interface hack, but something that we could do. So that I think the problem with the Bloom filter approach is that there's this overhead of building these Bloom filters for all I/O that you're paying in general, and there's no. Oh, I guess you can only do it when you're degraded. Actually, I guess that's the thing. So only when the PG is degraded do you actually maintain the Bloom filters.
You also take a terabit of memory though too. Like I think if you don't want it to be ridiculously expensive, then it was a byte per entry or something. Or not expensive, but so ridiculously overestimate what it's
Yeah.
or not. It's like a byte per entry, which
Yeah.
may be okay.
So let's say it's 10 minutes or of downtime, just as a reference point. Which would be 600 seconds times the IOPS would have noticed you do 50,000, say. That would be, that's 30 megabytes for 10 minutes. Not too bad.
Well, yeah, but then you have to like set it to that because you can't resize the Bloom filter either. And it's, yeah, I don't know. Maybe it's okay.
So we could do what the cache tiering did, where they're episodic, and so you build one for however long you want to build it, and then you write it out, and then you build another one. And that bounds the amount of memory because you only have the one that you're building in memory. But then when you're doing backfill, you have to load all of them up in order to. So it doesn't really save memory on the backfill portion because the number of Bloom filters will be determined by how big your window is. And there'll be more CPU, but you could reduce memory for the actual period while you're degraded. Are there like newer Bloom filter type things that solve the same problem? An old Goo filters.
So it actually, if we're gonna do sort of this permanent backfill thing, we might, like, if we're still ordering, then when the like replica comes back on, you know what version its PG is, right? So the primary can, I guess it still needs the versions of the objects, so they can just send over everything with the newer version tag. They don't even need to compare.
Yeah, I mean that's what it does.
Although no, because that doesn't get rid of deletes, I guess is the problem.
Yeah. I mean conceptually, it feels like it's pretty similar to what the hit sets did in that we had different hit set implementations. One was a bloom filter, one was just like a list of like it was literally just a list of all the hash IDs that we touched. Even doing something like that, where it's just you consume 4 bytes per IO and you just build it up, would be significantly more efficient than what we do right now with a PG log, because a PG log entry is, I don't know, like 200 bytes per entry or something like that. That's like almost 2 orders of magnitude less memory. And if you compare that to the bloom filter is going to be like maybe like 4 times more efficient than that. I'll be right back.
Is this what you were looking for, Josh, or did you have other targets of interest for making backfill better? Not sure if no one heard me or if Josh isn't like this.
Yeah, Josh seems to be muted or something.
Yeah. Sorry, hard button on the cord there. Yeah, so I guess the other avenue I was thinking about was that this is essentially the same problem that rsync has, where it's trying to optimize transfer time for copying a certain amount of data, and that's another aspect we could look at. So not just not optimizing the scanning part, but optimizing the actual recovery part.
So, but I mean, the way rsync works is it preserves network bandwidth, not everything else.
Yeah.
Which I'm not sure is actually a good trade-off for these systems. And I guess we can model out what they are, but I would actually expect that would be a bad trade-off if we're talking about the impact of having to decode O nodes, then the CPU involved in like doing the data read, and then like, because that is building up Merkle trees of the actual data blocks and figuring out where they differ. Or maybe not literally that, maybe it's something slightly less sophisticated, hashing data.
Right. I mean, the more basic approach, I guess, is not keeping track of any index online, so you don't have any impact to regular I/O, but just going when you're doing the enumeration, perhaps also reading the data from the objects and then dividing that into subsections and computing on the fly, like hashes or constructing a Merkle tree out of that if it's a very large object, I guess.
Are we still talking about backfill?
Yeah.
Yeah, I think if we go beyond having to look at the version, then we're going to lose, right?
No, I'm talking about if we want to try to optimize like the data transfer as opposed to the scanning.
Oh, I see. Actually recovering an object. Yeah. Oh, yeah. Right. Because for log recovery, in theory, someday soon we'll have the delta extents, but we won't have that for yeah. I think probably the way to do it would be to parallelize it, because you could load in some part of one object and send or build a Merkle tree or whatever of the object and send it across.
Mhm.
And then while you're waiting for the other side to like do the same thing and compare, you would work on loading in the next one. And then the primary would say, these are the bytes I want. And then you would read them back and then it'd do the same, whatever. You have to pipeline it.
Yeah, definitely.
So it'd use a little bit more memory, but you could end up probably significantly increasing the throughput by doing that. It'll make the backfill code more complicated. It's already pretty complicated, but it's also pretty stable. I don't think we've touched it in a couple releases now, which is good. Yeah. I think the alternative to that would be on each object have like a mini log that's like recent changes. But like the last 5 updates to the object, and maybe you collapse them down or something in a fixed size vector. And then if you're lucky, there's only like one change, and you will see what extents have changed and which ones haven't.
Just showing the exact delta for the last 5 operations or something, or
yeah, just like the extents that are modified. Yeah.
Yeah.
Yep. You could even could you do like a power of 2 thing where like every other IO you like OR it into the last entry, and then it moves down one and ORs it in, like depending on what the bits are. You could have a sequence counter. So that way you have like the last 1 entry, the last like 3 entries, the last 7 entries, the last 15 entries, or whatever, kind of like that powers of 2. You do something like that too. And you just union those vectors together.
Yeah, that works nicely for extent-based stuff, I guess, but not for like
not permanent
matters.
Yeah.
Going back to the bloom filters, if that was the approach we took, can you walk through a little more, Sage? So like, are you expecting that the backfill target gets sent the whole set of bloom filters?
Yeah.
And so they both walk through with that, and the target sends all the metadata about everything that matches.
Exactly.
And so does the. Okay.
Yep. So.
So that's how so it would detect deletes because it would say here's an object, and then the primary would say that's gone.
Right.
Get rid of it, or.
Yeah. I mean, you would sort of logically be masking what the backfill is looking at by what the bloom filter matches. And that would include deletes.
So let's say that instead we stuck with the hash ranges we have right now. Couldn't we do something like? Well, so what I'm thinking is that if we don't want to pay the cost of maintaining those filters, we can do something like just take a hash of the object names within a hash range and swap them, and then the replica can also say what the versions are of every object in that range, because presumably the replica has CPU to spare because it's not doing IO
yet. Yeah, I mean that's 1 PG. It's 1 PG, but yeah, you could do that. This is kind of what our thing does.
And so the replica. I mean, maybe this is wrong, but I think for the sake of argument, let's say that the replica can afford to do the ONODE decoding. So the replica can actually along with the hash of what object names there are, it can say the newest version it has, the oldest version. Oh shoot, maybe that's not important. I mean, there ought to be a way to construct something where we can figure out if the versions matter, but maybe the primary is that.
I mean, you could literally just build the backfill tree for the entire backfill and build a Merkle tree out of it and send that across, and then go back in detail and do the pieces that matter, like something like that.
Well, yeah, but how would you identify the pieces that matter if you didn't already have a filter? Because if we already have a filter, then the Merkle tree isn't.
Yeah.
So
right, because you wouldn't have it on the primary without building it either. I mean, maybe looking at the ONODE is getting ahead of ourselves, because we have to look at it. Right now, backfill scans everything. It loads every ONODE, it looks at the attribute, whatever. So anything that reduces the amount of work is an improvement. I think the question is how much can we improve it? I think the thing that worries me about building that big Merkle tree on top of the whole thing is that it's a moving target. because you're also writing to the PG at the same time, and you have this like cursor as you move across and bring things up to date. So we have to be a little bit careful about.
Yeah, well, I mean, you can also do the one hashing entirely.
Because even if in principle you wanted to scan the whole range and build up a Merkle tree on both sides and compare it, the primary actually can't do that because it's also doing IOs. So it's built a Merkle
Yeah,
tree
that's what
on
I'm saying.
something
You
that's
can also
changing.
just like scan over a range and
Yeah,
build up a smaller.
right. Yeah. Yep. On a smaller window. Yeah. I think I still like the bloom filter the best. But let's see.
Like realistic data structures. And everyone's at work. Just and if we want to get really advanced, we could also start doing like we could like start we could maintain a PG log but turn it into Merkle trees of the objects themselves. Where it's just like the PG log is right at log and then we maintain the metadata for the whole structure for the whole PG. That would probably be very fast.
So
walk down into specific parts that have changed. I don't know what the IO patterns look like though.
So how about this? So this whole problem is sort of assuming that we have the same basic functioning of log recovery and backfill and so on. What if I think one of the weaknesses in the way that we do things right now is that there's ever a degraded mode. What if instead of if you have replica count 3 and one of them goes offline, instead of just writing to 2, we pick a replacement third that we record in the past intervals, but is like a sort of an observer witness role basically, and all it does is it just journals every transaction that goes by. The same thing that the subop is sending across, that's like delete, set attribute, whatever.
Definitely talked
and
about
then
this before.
Chain those together, yeah.
And I like the idea, but I'm pretty sure something was super hard about it.
Yeah, it's a big change. It makes the whole log recovery thing totally different because you suddenly are piecing all these bits and pieces together. You might have different sets of these like witnesses covering different time ranges, and you have to like string them all together.
Also lose them.
You can lose them.
Yeah, so we need to recover from not having them anyway.
Yeah, but in the general case where you just lose one replica, wonder if it actually makes that much difference.
No, I mean if you're relying on these log replicas to recovery, then you need to deal with losing the one log replica, or you need to start doing only log storage to or that doesn't actually work.
I guess what are we trying to gain out of having the log replica?
That's what I
if we're
just
not
realized.
Getting full redundancy.
Right.
We need the log replica in combination with a full replica to be able to reconstruct. True data.
If you've stored 1 million objects and you lose one replica, you now have 2 replicas of 1 million objects, and you have 3 replicas of the 200 that you've written since then. Are you actually any better off? I guess it means that
unless the full replicas switch their mode, then you haven't gotten yourself anything, because if you just lose your log replica, you still need to go through like some kind of scan.
Well, it means that it's the situations where right now when we get into peering doesn't have enough replicas of recent writes or whatever, and peering gets stuck, we have an incomplete PG. Basically, that wouldn't happen, right? Because we would never go read write unless we were actually writing 3 copies of it somewhere. I guess it could still happen, but it'd be that much harder to happen because you'd have to lose another n devices for every interval, basically.
Yeah, you're also making the recovery more expensive though by actually doing those extra writes. You're increasing the I/O load in the cluster as a whole.
The degraded. It means that when you're in degraded mode, it's probably about the same as not being degraded, because instead of actually writing the write, you're writing the transaction.
Right, but you still have to do the backfill at some point, and that's not
Yeah.
going to change.
Yeah, but it won't change backfill, I guess. Well, it would sort of capture what you were talking about of having an efficient recovery of one object, as you would actually have.
That's true.
Assuming it's a small number of transactions, you would have like the 12 things that happen to that object. If it were like 1,000 things, then it might be slower than just recovering the object, so that's probably not.
But if
and
what
you could
you're
always,
actually interested in is sort of always having the backfill information, you can do that with Merkle trees too. Like there are storage systems where they just maintain Merkle trees of their metadata, and if they need to do like a repair, they walk down their trees, and then they ship over the parts that differ.
Maintaining the Merkle trees online is a thing that I think that's not super feasible, because that means for every write you have login Merkle tree updates that you have to persist, right? And I think that'll be prohibitive.
I mean, it depends on how you persist them. It doesn't need to be that many writes.
Right, you have to calculate them.
Your log structure thing, or you need to calculate ones.
Yeah.
You generally use a cheap hash.
And if you use a cheap hash, then you risk collisions.
Well, so what I was thinking of is that you like make things that presumably you wouldn't actually like maintain the PG, like a log of the stuff that's changed, then you clean it into a Merkle tree, basically like an SSD. As you go. Because then you can pull less stuff that's happening on objects.
When you compact each
I
one.
didn't prep for this, so I don't know what the actual math works out.
Yeah.
It seems like that wouldn't be too bad.
Yeah, you would like amortize the calculation of higher things at the hash when you like compact it or whatever. Yep.
I mean, presumably you wouldn't actually do each object as word. It would be like some kind of hash range thing. You have to design it carefully. Because then the backfill really is cheap. You just like walk down your Merkle tree where the word is.
Yeah, you'd have to like freeze it.
Exactly which sets of objects. Maybe.
Yeah, I guess maybe not. You're modifying on. You have to have an online view of it.
You might just do it the same. Like you might just do it with the sort of backfill cursor that moves forward. So.
Are you writing these down? Yeah. Okay. Bloom filter.
I mean, we have to do some kind of freeze no matter what our recovery is, so I'm sure we can cover the blocking system doing this.
Okay. Yeah. I think the first step should definitely be to get that incremental recovery thing, pull request into shape.
Yeah, I think last time I ran through, it was still failing a whole bunch of tests in the Rados suite.
Okay.
Yeah, probably need to go and take a closer look at that.
Yeah.
Help them out.
Yep. Okay. All right. Do we go to the next topic? Hey, Noah. Good to see you.
Can you hear me?
Yep.
Hey, how's it going?
Good. Good to see you.
Yeah, you too. So yeah, I had a quick question. So we are in the process of putting in a manager module, going to be exporting sort of a big chunk of data out to insights. And one of the things that we'd like to publish to insights is a history, like 24 hours or something, of the different health checks that have failed. And it's not so hard to do as it stands now, but there can be a fairly significant delay between a check being pushed into the monitors and the manager actually getting it. So we're a little worried about flapping errors that you like miss.
Yeah.
And so it seems like the proper thing to do is to add like a subscription, like a sub feature, which doesn't appear to be there for the health monitor.
Yeah. Yeah. It doesn't. And then I think that the key thing though is it needs to have a versioned history that the subscription is following, so you can like have a position. I can't remember if the health monitor currently does that right now.
I think that it might just keep an arbitrary history of like the last 5 or something.
Yeah. Oh yeah, that's what it does. Yep.
Okay.
But
So
we could do. Yeah. So I think there are 2 options that come to mind. One is just that, make it so the health monitor keeps N of them instead of 5. Because right now it actually never looks at them. It only uses the most recent one, which is why it's hard coded at 5. It really doesn't matter. I think that the one thing challenge there is that what it's actually storing in each of those states is the current health, which is the whole, all of the health checks at that point in time. And so they have this big blob dictionary that'll like shrink and grow and whatever. And so if you want to get like the delta, then you have to like calculate it out each time, which might not be ideal. The other way might be that we could make the health monitor, it already has some code that's generating the like incremental update messages and logging them. We could make those go to a custom log channel, and then you could subscribe to that log channel, and we could put them in a separate log file and like make that be the structured thing.
Okay.
The challenge there is that right now those log files are like, traditional log files with 1 line per entry. They're not like structured, although they could be, I guess.
Okay.
I guess it's not really any different in that case than doing it in the
Yeah. So I think so we were looking. Okay. So yeah, we see the log. You're right. It's not structured, which was kind of a pain to interact with. Okay. It seems is there any, I mean, are people putting structured data into that log? It seemed like it was human readable when I was looking at it.
Right now the cluster log is human readable. I mean, maybe we should have structured logs, and we can make, it has a concept of channels, so we can make channels that are structured and other ones are human readable. We could do that.
Okay.
But if the only point is to log, I think it depends on what you want to consume. If you want to consume a sequence of states where each state is a set of health checks at that point in time, then it's easy to just build it into the health monitor, add a subscription function, and you'll get a series of updates, and each update is the full blob. On the other hand, if you want to get like a series of deltas that are sort of the structured equivalent of what you get in the current log, where it's like new health check, updated health check, cleared health check, then put it in the other place. I can't actually remember where that is.
Yeah, so it seems like there's, yeah, okay. I mean, you could also not send the delta. You could also not add the complexity to send the deltas and just do like deduplication in the manager module or something. I don't know.
Or could do both.
Yeah.
So I just found there's this helper function in the monitor code called log health that basically just looks at the previous checks and the new checks, and it generates the log messages.
Okay.
So you could just, in addition to generating the human readable log messages, it could generate a structured log message in a different log channel.
Okay. All right. I'll check that out.
That would be easy also.
That's cool. Yeah, I don't know much. I'll have to go dig into that, but that sounds reasonable since we're already subscribing to the channels in the manager.
All the log channels, that might be.
The audit law. I actually don't know. I don't anything about it.
If it's not subscribing to all of it, it probably should just have all of them in memory or whatever.
Yeah. Okay.
Yeah. But yeah, log channels are easy to add. I think we don't have a lot of history on those. But it's whatever. It's probably fine. If the manager is down for a long time, then you might miss some deltas or something. But
okay. I mean, I guess if adding, yeah, it seems like a good. Well, I don't know. That's like 20 different ways to accomplish something. So.
I know. Yeah, you have to decide. I think you have to decide whether you want a structured thing that tells you what new checks are, updated checks, and cleared checks.
Yeah.
And a sequence of those. If that's what you want, then having it log a structured version of what it's logging to the human log is probably the simplest.
Yeah.
And if you want the full shebang and to do your own whatever kind of delta notification stuff on the manager end, then you should do the other thing. It's one of those two things. I wouldn't worry about the history part because the log monitor is already like kind of broken in the way it's implemented. It needs to be sort of restructured so that it can preserve and more efficiently preserve more history. The implementation was sort of a hack to get it to work quickly with minimal changes, but it's far from ideal.
Okay.
So that can be fixed separately.
Okay, I'll poke around. I think there's some more questions to answer. So
yeah,
sounds good.
Okay.
Cool. Thanks.
I imagine the same set of considerations are going to come up for the SNMP module too, where it has to emit traps for health alerts, but I don't really know how SNMP works. So it might be worth having a conversation with who's looking at SNMP. Whoever's looking at SNMP. Somebody who's working on the SNMP thing. And see if there's overlap there.
Okay.
Yep.
Cool.
Cool. Okay. Sounds good. Anything else? Short and sweet.
That's all I got.
Well, yep. All right. Have a good one, guys.
See ya.
See you later.
See ya.
Bye.